Okay.
Good evening. It is September 28th, and we're going to work on start chapter lesson 2-1, so unit 2. I wanted to, first of all, for anybody that's watching the video, I'm going to send out an email, but the unit 1 project, I know it's clunky. I know a lot of you don't know Excel already, and I know many of you have put lots of hours into unit 1 project, but I want you to know to take a deep breath. I'm going to be not skimpy on my grading, but I'm going to be flexible in my grading because I know you put a lot of effort into it and you're, doing the best you can. A couple things. The first part with the where you're spending your time, don't worry about giving me percents of all your subcategories. Just forget the subcategories if you want. Just worry about your main categories and give me your percentages for the week of what you planned and the percentages of the week of what you actually did. And then that's where you're going to do a comparison. You're going to pick one of those and you're going to do your comparison for the questions down below. So try to make it easy on yourself. I would like to see the pie graph to see you can do that. If you want to draw it by hand, I don't care. If you want to do the bar chart by hand, I don't care. I want to make sure you're just learning something about what we're learning in class. The apportionment, I did a whole extra video about that. So if you watch that and you still have questions, I don't mind meeting with that as well. The unit 2 project, I'm going to be putting that up this week yet. I'm trying to get all caught up. That's going to go up in the next day or so. I'll probably talk about it on Thursday. But the unit 2 project, actually, I can kind of show you because I forgot that I do have it up. Over here. And can you all see my Desmos?
Yes, I can.
So I'm going to show you the unit 2 project. There's a 2 tasks to it. And it's going to be, I'm going to give you a link to Desmos and you're just going to basically answer everything in this link. And then you're going to save your own link. So just make sure you have a free Desmos account. And then you're going to save it. And over here to the right, where up by my name, there's a little arrow box you'll click on. And then it gives you a link that you can copy. And you can upload the link in JetNet. So if I take that link and I copy it, I'll show you how to upload a link. I'm going to turn off my. So I'm just going to pretend that I'm doing a link here. That's not what I want. I'm going to show you here. Well, actually, while I'm doing that, you all can kind of read through. So it's going to be on here. And here is the actual project. There's 2 parts. You're going to be picking a company, or it's called a stock. A stock is a purchase of a company. And you're going to pick one that you want to follow. We're going to be doing more with that in unit 3, but you're going to just pick one that you want to follow. You can go to either of these websites. The finance.yahoo is the easiest one. You can just type in at the top the company, and then it's going to give you their 3-letter code. And then it'll take you to a page that has a lot of information on there. And you really just need to use the opening value. And I'll show you that here in a minute. Okay, so you can see that I chose Disney. So my group is DIS, that's my code. And then right here where my mouse is, it says open, and it opened at $176.63. I just want you to track that for 10 days. And so in Desmos, you're just gonna put day 1, day 2, day 3, day 4, day 5, 6, 7, 8, 9, 10 days, because 10 days is actually 2 weeks in the business week, because the business week is only Monday through Friday, Monday through Friday. So it doesn't matter if you start tomorrow, if you start tracking and you do Wednesday through the 2 weeks of Wednesday, that's fine. So 10 days, and you're just going to put in the amount here. And then as we go through unit 2, we're going to learn about linear modeling, and we're going to learn about exponential modeling. And you're going to tell me which model is the best here. Okay. Well, I'm having you do just a linear model on that. And then, so you'll answer those questions, you'll save it, and then I'm trying to get into JetNet here where I can show you how to do a link. And I'm gonna show you that. Then let me take you back so you can read that while I'm switching over. The second, and then you're gonna answer some questions. The second task is about scaling a recipe. So in lesson 2-3, we're going to learn about scaling. So how to scale up a fraction and scale down a fraction into a unit rate. And we did that actually in unit 1 a little bit, unit rates. And so we're gonna build on that just a tinge in 2-3. It's not much, but I'd like you to find a recipe. You have to let me know how many people it serves, how many servings. And then question number 3 says, I'd like you to rewrite the recipe. So all of the ingredients, you need to scale them down so it only serves 1 person. And then you need to do it again and scale them up so it serves 100 people. And so that's kind of all about scaling. And then if I can get this to work, I'm going to pretend like I am uploading. Okay, so I'm going to share my screen here. So now you should be seeing, I'm pretending that I'm uploading something in a class. Can everybody see my JetNet screen? I'm pretending that I'm a student. It says Unit 1 Review B, but it's just to show you an upload. So I'm going to say add submission. And you can add PDF files. Oh, I only accepted PDF files in this one. Oh, chase. Let me go to one where I've accepted something else. Mrs. Main. Well, I'm going to get everybody working on something, and then I'm going to go to that and I'll set it up so that I can show you how to upload something other than a PDF file, because you can actually upload links, which is really nice for all the projects. So if you want to upload a link for unit project 1, I'll go ahead and change. That's what I'll do is I'll change to project 1 so that you can upload a link, and you'll see what it's like to upload a link from the internet. Because if you just cut and paste a link into on a piece of paper or a document and then save that and upload it as a PDF, it's a PDF. I can't click on any links, but there's a way to upload a link in JetNet, which is really cool. So I'll show you that in just a moment. But everybody else is going to turn to my people that are live and those watching the video. If you turn to page 125, we're just going to get started in unit 2.1. And it's all about interest. So interest is a fee paid. Sometimes the fee gets paid to us, right? If we put money in our bank account, a savings account, or a certificate deposit, it's called a CD, or a 401k. Savings accounts hardly pay much of anything. Or if we loan somebody money, we could write a promissory note that makes sure that they're going to pay us interest back. But a lot of times it's us paying somebody else, right? We're paying the bank for a car loan, or we're paying the bank for our house loan, or we're paying the bank for a personal loan or a credit card. So that's the most time that we usually use interest. So there's 2 kinds of interest that we're going to talk about today. One is simple interest and one is compound interest. And would either of you ladies be willing to read the simple interest for us on the bottom of page 125?
I can. I'll read it out of my book.
Awesome.
Okay, simple interest is calculated as a percentage of the original amount of money. For example, if you deposit $100 in an account that pays 4% interest per year, at the end of 1 year, you will have 4% of $100 extra in the account. Since 4% of 100 is 0.04 times 100 equals $4. You have earned $4 in simple interest, and the account would now be worth $104. In the second year, you'd earn another $4 in simple interest, making the account worth $108.
Awesome. So simple interest, we earn interest on the original amount every single time. So we're not earning any interest on what's left in the bank account. It's just on the original deposit, unfortunately. Okay.
But you're not spending it, so you're not spending the money, so
no. But I mean, if I'm leaving it sit there, I should be earning interest on it. That's
right.
I see it.
Yeah.
Okay. Would you be willing to read how they explain compound interest on the next page for us?
I will, if you want me to.
Awesome.
Okay, compound interest, on the other hand, the force that Einstein was so enamored with is interest that is paid on the original amount deposited, but on interest previously earned as well. To help you understand the difference between simple and compound interest, let's look at two different accounts.
Okay, so we are going to look at account 1 and account 2. So account 1 is you deposit $1,000 into an account that pays 5% simple interest on that $1,000 each year. Then account 2 is you deposit the same $1,000 into an account that also pays 5% interest, but it pays the interest on the account balance at the beginning of the current year, which is awesome. So down in question 3, if you want to get started, it says, how much interest will you earn? And then it says first year, second year, third year. And then it's also giving you how much will be in the account at the end of the first year, second year, third year. And it wants you to only use account 1. So that's the simple interest account. So I'll let you get started. So what did we figure out for the interest on the very first year?
$50.
$50. Okay. I'm gonna have to go back and do that later because it's killing me here. And let's go ahead and I'll share my screen here. So the first year we had 1,000 times 0.05, so we earned $50. So after the first year, we have 1,050.
Mhm.
And then what about the second year? How much did we earn?
Well, that's where I know what the common thing is. You earn $50 again, but if you had $1,050, and this is just me, $1,050 the first year, the second year, why wouldn't you earn interest on the 1,050 instead of the 1,000 again?
Well, that's what I said on the front page. And you were like, well, you're not using it.
No, I mean, I was just saying instead
Right.
yeah.
So that's exactly it. So with simple interest, that's a great point, Teresa. With simple interest, it is a bummer because you don't earn interest on all of the money that's sitting in your account. You only
Right.
earn interest on that original deposit,
Oh,
right?
okay, which was the original $1,000. So every year, doesn't matter how much you have, you're just gonna get it on the 1,000 you initially put in.
Right.
Okay.
Even if you leave all your money in there, all the money over the years that you've earned that $50, you're not getting interest on the 50, you're just getting interest on the original 1,000. Yeah, it's not a good deal for
No,
anybody. Well,
no.
for the bank, but that's it.
Yeah, it's simple. It's simple for them.
Right. Okay, so then the second year, then our value would be the 1,000 we had originally, the 50 from the first year. And then I'm gonna just use a colored marker to show you that this is the second year, 50. And so now we have 1,100 in the account. Okay, now the third year, we said we also only earned 50. So that means our total balance would be the 1,000 from the first year, 50 from the first, 50 from the second, and then 50 from the third. So we have 1150 in the account. And up here, it did say, make sure that you think carefully about how the amount is growing and look for patterns. So do we notice any patterns and what?
As in, it's just 50 every year. It's like 50, 50, and 50. So it's
Mhm.
53 times.
So one connection we can make is whatever year it is, it looks like that's how many 50s we've added, right?
Correct.
So third year, we've added 3 50s. Okay, so that's something, a connection that we could make that would kind of maybe help us. Okay, now I'm gonna have you go and think about, we're repeating what we did up here in question 3, but we're using it for account 2, where every year the interest we earn is based on our previous balance, which is the way we would all assume we get interest, right?
Right.
So I will keep working on that. And I'm going to move this over here. Share my screen so you can see my paper again.
Darla, your background looks almost 3D blurrish.
It looks what?
Like it's 3D, but it's blurred behind her.
Oh, it is. Yeah. She doesn't want us to see her Christmas stuff. I don't know why. I love it.
Wow. I love Christmas.
It distracts me
Oh.
because when I'm looking at the screen, I can see all my
See
stuff.
it in the back.
So
Yeah,
it's
yeah.
distracting my eyes.
Yeah, yeah.
So yeah. Hey, it takes me a while to get that. I can go and unblur it. Background, none. See, then it becomes a distraction
Oh,
because I see it.
but I like looking at it.
And I want to go.
I got a picture behind me on the wall.
I've got stuff over here next to me I need to cut. Well, I do.
Should I put those hamburgers in the microwave?
No, they'll cook.
Okay.
Thank you.
I have my dinner in the oven.
We can take a dinner break here in a minute.
Oh, mine won't
No,
be
mine-
done.
will
Mine
take a
won't be
while.
done for a while, but yeah, mine too. But if you need to, I can always go take a stretch break or whatever. I'm surprised there's only 3 of us on here.
I know.
2 of us.
Everybody's missing out.
Well, even though I did the video of you doing this earlier, I still like to sit in just in case I miss something or you have little extra notes about something that I can write down because I want to use as much information as I can possibly.
Hmm.
And I tell you, I personally will be glad when we're done with this project. First one, it is it's pushing my limits here.
What is?
Project 1, it was a lot more than I anticipated the work for it. But and then when I got to the last task, which is a part that I've kind of picked up on and have done, and then I couldn't click on anything because it was read only. But then I see you did do another. I sat in on it the other day when you were with was it Brandon?
Oh, one of
you-
my students, Logan.
Yeah, Logan. And I sat and listened and to explain, so that helped me a little more to do it.
Oh,
So
good, good,
yeah, it helped.
good. Okay. Did you get the interest for the first year, second year, any of those so far for the second account?
Well, to me, the first year is the same as the other count one. And it was the same amount percentage, so it should still be the same dollar amount, correct?
Right.
$50.
Yep, so I still got a 50, and then, so this is still gonna be just 1,050, right?
Correct.
But now we're earning interest on the $1,050.
$1,050. Yay, which is yay.
Right, so we're earning interest on the 1,050. So that now would be 5,250, right?
Yes.
So we just earned 2,050 cents more.
And
So now I'm gonna take my 1,000 plus my 50 plus my 5,250 and get my total, which is 1102.50.
Yeah, that's what I have.
So let me figure out, what about year 3?
So your interest the third year would be on the 1,102.50, correct?
I'm sorry, what?
The interest for the next year would be the 5% only on the 1,102.50 interest.
Right.
So it's like from up on the top, your answer from the top moves down to the next one, moves down for the,
Mhm.
yeah, right, okay.
so it should be 55.13 cents.
So
Or did I
55
get
and
it?
13.
Yeah, because it
Yep.
says 55.123, so I just rounded up.
Yeah, 55.13 when you
Now,
round.
do we always have to round up on stuff like this?
We're gonna
always
round
round up.
appropriately. The decimal is actually 0.12, like 6 or something. It makes, so you round up to 13 cents.
Okay,
It's 0.125, I think. So
okay, and that's what I did, so.
you're gonna round naturally, and the natural rounding would cause us to round up. Yeah. So, okay, so now my balance is 1157, right?
Yeah, yep,
63 cents.
yep.
Okay, and then if you want some more help, there's always this purple box you can go back and refer to. Are you both following along so far?
I am. Carly, you all right?
Yeah. Not very convincing.
That's okay. Stop us if,
Yeah, I don't mind sitting and listening because I'm telling you, there's some of these previous chapters we've done, when other people have asked questions, it's helped me a little bit, so.
yeah,
I just hope I remember all the stuff we take our midterm, all these different,
well, you're gonna write notes. You're gonna make a note sheet for yourself.
yeah. Okay,
So you've got kind of a note sheet, so things are quickly, it's not about like getting done really fast, but just so that you're efficient, like here are the main things I need, like the
right,
percent change and the actual change and all
okay.
the things that we've done.
That's it. I was talking to my husband, I said, oh my God, I hope I remember all the stuff. He says, you need to make a note sheet.
Yeah, we're gonna have a whole review night that
Okay,
we'll make
good.
sure that questions are answered back from a unit 1 review, unit 2 review, and then like what things would be good to put on your note sheet and all that other good stuff.
And you know what, as long as you leave up the individual videos that you're doing for each section, I can always go back and check those too. Because when we have class in Zoom and there's a lot of people, sometimes you know, you can listen to other people's questions, but if you go in and follow you doing those, then everything's answered and it's like, oh, okay, now I get it. So
Mhm.
that helps.
Mhm.
So thank you for doing that.
No worries. I have up through 2.3 part 1 done. So I'm going to finish 2.3 probably Thursday because I teach all day tomorrow, but I'll get that one ahead done. I'll be ahead then this weekend. Okay, are you up with us, Darla, on that? Where we got the 1157.63? Okay, now on page 127, it's kind of having us put it together, but just so we can do some comparison. So account 1, we knew we started with 1,000. We had 1,050 after 1 year. We know after
It
2 years, we had
stays.
1,100.
It stays at 1,000. What?
Well, this is
Account-
asking, what is our balance? So we started with 1,000, right?
Right.
And after
Right.
1 year, we had 1,050 because we had the first year interest.
In account 1, the first rec, it stays 1,050 the whole time.
Nope, we kept adding 50 to it, but we didn't get interest on what's over here. We only got the $50 interest. So we added 50 each year.
Oh, okay.
But I get where she's coming from because, yeah, that says fill the table next by finding the amount and account at the end of each number of years. So, yeah, but I see where you're coming from, Darla, too.
So our interest was only $50 every year, but we still got the $50 interest. We just weren't getting interest on everything that was in our account.
So that's
So
the
11,
compound. Yeah,
1150, 12, 1250.
Yep, so this should be,
Correct.
3 years would be 1150, 12, and 1250.
Yeah, that's what I got.
okay.
Okay, so we're all in agreement. And above account 1, I'm just gonna remind myself that simple interest. Keeping myself straight. And then
Well,
above,
I tell you what, it's gonna make me, if I ever had interest on something, I'll make sure I get the compound.
right. Okay, so account 2, we said we started with 1,000, we had 1,050, then we had 11,0250.
Then 1157,
And then,
63.
and then we need to do 2 more years,
Okay.
following what we did on the previous page.
57.63 times
Mhm.
0.05. That
I'll be
gives
right
me
back to check that.
1157.63 add 57.88 be 1215.51.
Okay, I'm back. Oh, Sandy's here, yay.
So Darla, you had 5788 and it came to $1,215.
1215.51
Yeah, that's what I have. Yep.
and then 1276.29.
Yep, for after 5 years. Yep.
Excellent. So let's look at number
Really?
20, number
20
60.
years.
Hi, Sandy.
Hi.
We're working on lesson 2.1. We're on page 127 if you want to join us.
My gosh, I can't believe it's 10 to 7 already.
Well, number 6, account 1 is simple because you're just adding 50.
Right.
But account 2, it would take us a little bit, but we could get to it. Because you have to multiply 0.05 each year.
Right, because the other one on the simple, you know, it's gonna be $50 every year, no matter what.
Mhm.
The other one changes. That one's gonna take longer to do it.
Right,
You
and
said,
so,
yep.
so the simple, you're like, oh, for 20 years, we got $50, right? Plus our 1,000 we started with. That one's pretty nice and easy.
Right.
But, and I could do 50 years, right? So 50 times 50, I could do 100 years. But the problem with this, what we know so far, we haven't learned everything yet, but what we know so far, this compound one, I kind of need the previous year, right, to guide me to find the interest for the next year. So as of right now, at this moment, all we know is I have to keep going year to year to year to year to get all the way to 20 years.
Right.
I don't,
Yeah,
I
that's
don't
what I
have,
was saying.
we don't have an efficient way yet. We're gonna come up with on here in a bit, but we don't have an efficient way.
Other than do it for 15 more years on the calculator
Right.
or decimals, whatever.
Right, well, we're gonna learn an efficient way now. Okay, so we all agree that simple interest so far is pretty easier to see that we're just
I can get it in a
repeat
minute.
adding of this $50. Okay, so now let's go down and see if we can rewrite our compound interest, like what we're doing, a little bit easier. So at the bottom here, it says, write the computation of the amount of interest in account 2 after 1 year in a single calculation. So we had our $1,000 and then we're adding our interest, which in the first year is just 0.05 times 1,000. So that's how we calculate the interest. So we can write this a little bit more efficient. They want us in part B, it says, we want you to write it with the distributive property. So the distributive property kind of works like a paper boy handing out newspapers, or the mail lady, right, driving by and putting mail in your mailbox. They're handing out mail to everyone. And newspaper wise, it's usually the same newspaper, right, from door to door to door to door. Okay, so if you had money, you would give money to each person, right? That's what you're distributing. You're distributing papers or money. Oh, neighbor dog's barking. So what we want to do is we want to move it in reverse. We want to be able to combine what things do they have in common. So you can see if they have $1,000 in common. Okay, so now instead of distributing and handing out the newspaper, we're like, okay, well, people, I'm collecting the newspaper back. So I'm collecting the newspaper back from everyone. Everybody that's got the same newspaper, I'm collecting it back. So that's what we're going to go down here in reverse of the distributive is called factoring. We're going to pull it back. So when we pull out that $1,000 down here, we really have a 1 plus the 0.05. The 1 right up here is hidden. We don't show it because the 1 and the 0.05 both represent a percent. The 0.05 is the 5% that we're getting on the interest. The 1 is the 100% of the original value that we're including every single time. Okay, so we've turned the 100% of this 1,000 into a 1.0, and we've turned our 5% for our interest into a 0.05. So when we say what's in common, the $1,000, we bring that up front. You are not going to have this memorized. I'm just explaining why it works, and then we're going to basically use a formula for the rest of the semester. So I want everybody to take a deep breath and go, okay. So just go, oh, this is really enjoyable. I'm understanding this. But right, when you say things are enjoyable, it does make them more fun, even though you might think it's not. So this is really cool. Look at, they both have 1,000, and I'm just going to write the 1,000 out here in front. Okay, everybody got the 1,000. And then that means I have the 1 from the 100% plus the 0.05. So if you flip the page, we can actually write this as such, 1,000 times 1.05. Is everybody following so far?
Mm-hmm.
Mhm.
And so the next year, we're gonna do the same thing. We're gonna take the 1,000 times the original 1.05, and we're gonna multiply it by another 1.05. Because we want last year's total plus another additional 5%, right? And then we want last year's total plus another additional 1.05%. So instead of repeat addition, up here, number 6, we can write repeat addition of $50. In number 7, it says, why does the value of the compound interest account grow faster? Well, instead of repeat addition, we have repeat what?
Multiplication.
Yeah, we have repeat multiplication. Okay. So get my paper here. 8 and 9 are asking us to fill in kind of what we know so far. So I'm gonna have you look at that for a minute and I'm getting my paper out.
I got it. Oh.
Sandy, if you need some catching up, let us know. Your hair looks good. Did you get a haircut?
Me?
Yeah, since last week? No?
No, all I did was take a shower and sleep. I was supposed to get a haircut today, but I went and got a COVID test. The
Oh,
rapid's
no.
negative, but I'm
Oh.
waiting for the other one. So I've already called in sick for tomorrow
You have to have 2 COVID tests?
because I'm having some symptoms,
Mm-hmm.
congestion, stuffy,
Oh, no.
super mild fever. So they're like, we recommend the rapid and the regular one. And I said, that's fine.
And is everybody getting sick at the prison?
No, I've been off since I've been off a few days. And last I knew, we about 2 weeks ago, we had one that was positive and she got out like the next day.
Oh, good. Oh, good. Okay, so for number 8, well, I hope you're not sick. Account 1 is growing by exactly how much each year?
$60.
That was $50, right?
50 buckaroos. So the amount after any number of years looks like this: $1,000 plus 50 times the number of years passed. Everybody in agreement with that?
Yes.
Number 2 says, let's look at account 2. Account 2 has its value multiplied by 1.05 every year. So the amount after any number of years looks like this: 1,000.
1.05.
1.05, and we have ... because depending on the number of years we're doing it, there's going to be different 1.05s, right? Okay. So the purple down here, these purple things might be good for you to circle or star because they might be some good things just for you to put on your note sheet. So this is like getting to the culmination of the big part of what we're doing today. In account 1, the simple interest account, the values grow by blank, the same constant number. So what is the math thing that we do for simple interest? They grow by doing what?
Addition.
Adding, yay. Adding the same constant number. This is called linear growth. Woohoo! So linear growth is our first type of growth that we're going to talk about this semester. In account 2, the compound interest account, the value grows by
Multiplying.
yay, multiplying by the same constant number. Multiplying. This type of growth is called exponential growth. We're going to do some Desmos today, so that's going to be exciting. You're going to get to see what it looks like. I'm going to draw you a quick picture. A linear is going to be a line going slightly up, slightly down, straight across, or up and down. They're going to look like that. Exponential growth is gonna look like this in some fashion. It might go really fast, it might grow really slow, but it grows something like that. Now, if you're going into respiratory health or any of those, you might also talk about exponential decay. So has anybody ever had any, I think they're called EEGs or EK, I think EEG, where they, EEG is on your brain. No, what is
The EKG for your heart?
no, not a, I'm not trying to play $25,000 pyramid. I really
EGG?
don't. No, it's the thing where they put a dye in your system so they can like see your kidneys, or it's like a
That's a
radiology,
contrast CT scan.
a CT scan. That's what it is. Yes, you guys are genius. So
Diagnostic imaging was last semester.
cool. So in those, right, they ingest that dye, and I've only had one done once before, and they're like, it might feel like you have to go to the bathroom, but you really don't, like it, because it goes in your system so fast and comes out so fast. That's what you talk about with exponential decay, which is a whole fun other conversation, but that's a different math class. But I do love talking about that. But today in our semester, we're only talking about growth. So it's only going to kind of go up like this. Everybody with me? Everybody's got, all my visual people have a kind of picture of what things might look like in Desmos. Linear would look anything like these four over here, and exponential is going to look anything kind of like these three here once we get to Desmos graphing. Okay, so this might be a good spot. We're gonna kind of, we're continuing with these topics, but we're kind of going to a different set of numbers. So everybody want to take maybe like a 3-4 minute break or whatever, and we'll come back. You can move along if you want on page 129, and then we're gonna build on this just a little bit.
Okay.
But it's gonna be the same two topics. I'll pause it for the.
Okay.
So before we go to the second part of lesson 2.1, I'm going back to unit 2 project. I was showing everybody how throughout the rest of the semester, there's going to be times where you might want to upload a link from Desmos to submit for one of your assignments. So for unit 1 project, if you have a need to submit a link from a website link or something, you can do that. But unit 2 is going to be all part of it's going to be submitted through a Desmos form that I created that you're going to answer questions and use Desmos in, and then you're going to send me a link. I showed part of it at the beginning of the semester, or the beginning of the night. I'm going to show you. Can everybody see my Desmos screen right now?
Yes.
So this is what that form looks like. I explained a little bit earlier. I'm going to make a whole project video that I'll upload, but I decided to bring it up because I know a lot of people are like, I want to be thinking about this. Over here where my name is, you can click on this arrow and it creates a link, and then I can copy the link. And then I'm going to pretend like I'm in I'm in JetNet. I've clicked on the project. This is unit 1, but just pretend. And I made other options besides a file. So other files that you can upload, you can use things here. So does everybody see this one that looks like an infinity symbol right here? And if I hover over it, it says link. I'm going to click on that. And then I can copy and paste. So Control plus the V Victor key lets you paste. And then I would appreciate if everybody clicked on the open a new window. So that, and then you'll say create link. So it creates a link for Mrs. Main to see. And when you click on the open a new window, when I click on it, it opens in a sub window. If you don't click that box, it takes me out of your JetNet assignment, and then I got to go back into the JetNet thing. So I always, and if I've missed one in my JetNet, let me know, because I try to make sure I always do open a new window for you all, so it's less pain on you. So I'm gonna delete this, and I'm gonna show again real quick because I know Darla walked away. So if you want to upload an assignment and you have a link like from Desmos or any website link, you can click this fancy, it looks like an infinity symbol, and then you're going to go here and you can paste whatever you need by right clicking, or Control V lets you paste. And I just ask that everybody clicks this back right here that says open a new window, create the link, and then there it is, and then you're going to save changes. And then I'm out for that. Okay. So, so let's go back to our page in the workbook and we'll finish lesson 2-1. So far we've been talking about, we learned about simple and compound interest. And then in addition to that, we found out that some simple interest is really just a linear model equation, and compound interest is just an exponential model or equation. So is everybody on page 129?
Mhm.
So it says, here's the
Yes.
key observation about the repeated multiplication that occurs when finding the value of account 2 in a large group activity. Repeated multiplication can be expressed more concisely using an, how can we write repeated multiplication a little bit more efficiently?
Using exponents, right?
Mhm. Yep, so we're gonna use an exponent. So the rest of the lesson is kind of putting some formality to these linear and exponential equations for you. So it says, let's continue working with the 2 accounts. And we're gonna go with the one that is $1,000 initial, 5,000 or 5% compound interest, and the value of that account after 7 years, it's gonna be by this expression here. It says, without using a calculator, write that expression without any exponents. Don't perform the calculation, just write out what it would look like.
So because it's multiplication, is this meaning this is compound?
Yep, this is basically our compound interest formula. I'm gonna formalize it with symbols
Okay.
in a minute.
Okay.
Yep. But they're saying,
Uh,
oh, go ahead.
No, because yeah, because just trying to remember, the simple was addition and the multiplication was the compound, correct?
Yep.
Okay.
And instead of writing it with this exponent of 7, we want to write out what that would look like. So we've got 1,000 times 1.05, right? Yay, we're gonna let Sandy share her paper. And I'm gonna put it on speaker view for me. You can all put it on speaker view if you want. So Sandy, talk for just a minute so we can all, so you're on the main speaker view.
Oh, hello.
There you go. Keep talking. There it is. So there
1,
should
2.
be, go ahead and count it.
I should have, let's see here. 1, 2, 3, 4, 5, 6, 7.
Excellent. So 1,000 times 7 of those 1.05s.
That's what I got.
Everybody else get that too?
Mhm.
Excellent. So there should be 7 of them. So it says, what is the value of the account after 7 years? So that means go ahead and perform this calculation up here. And put that down here. So what is going to be the value of that after 7 years?
Hmm. I have an answer.
Okay, what'd you get?
$1,407.10.
That's what I got. Is that what everybody else got? $1,407.10.
I used a calculator. Don't anybody think I did it that fast?
Mhm, mhm.
Awesome. You are super fast. And just so everybody marks this one, this is the lesson check question for 2-1. So I always try to give that pointer to everybody.
Which, as a student, I am very appreciative of you doing
Yeah.
it.
Well, especially you're here. If you're either watching the video and you got to this point in the night, praise be ya. And if you're
Yeah.
live, really praise be ya, because you're sitting and tolerating me. So it's the least I can do, because it should be a
Yeah.
free attendance thing, you know, I'm really not trying to.
Like
sell
she's really
anyone.
hard to tolerate.
Yeah, that's what I'm going, right.
Exactly.
Well, I'm glad you're all still talking to me after this Unit 1 project, so.
Yeah,
Well, the deadline hasn't passed yet,
I'm not done yet.
right?
And everyone knows that I give a little grace. Now, if it's 3 weeks and you're like, can I still turn on my Unit 1 project? I might say,
geez.
No, but I try to give grace to everyone. Grace has been given to me much, so. Okay, so number 4 says, in account 1, where the interest is simple, the account value goes up by $50, right? This calculation each year. Write a calculation that would find the value after 7 years, then find the value. So I'll let you all come up with one, and then we can share it. I'm gonna mute for just a minute. I get a voice message. So.
All right, I hope I got that one.
What'd you get?
I got 1350.
1350? Yep. Darla gave us a thumbs up. Tracy, you're good with that?
Mm-hmm.
So 7 years times the $50 plus 1,000. So we got 1350. Excellent. You guys are, ladies are really getting the hang of this.
Now, I wrote mine different, but
Yeah,
it's
the other
probably,
way.
I wrote mine so that it was 1,000 plus, and then I did my parentheses of 7 times 50, which is essentially
Yeah.
the same.
Yep.
So it
Right.
doesn't matter.
Nope.
Okay.
Okay.
So, it really, we kind of want it to be 50 times 7 because I'm going to give you a hint. Our linear equations are going to be y equals, and then it's going to be this b, we're going to call it, which is our y-intercept, it's our starting value, and it's going to be plus mx, where x is our years or our time, and m is that incremental change every year, which happens to be the $50. Don't get in a bunch about this y equals b plus mx. I'm introducing it a couple lessons early, and that's okay, because sometimes it's good to see things, and then when it comes up, you're like, oh yeah, we had a conversation about that. So you're seeing all the pieces now, you just don't know what the pieces are yet, which is kind of cool. Because you're not afraid of them until you start seeing the letters and everybody starts.
Right. You're
Well,
you know,
it's
you
true.
look at it,
because
go, oh my God, I'm so confused.
right now, we all know what the 1,000 means, right?
Right.
It's our original value. We all have a common language what the 50 means. It's our interest for a year. And we all have a common language of what the 7 means. It's our years. And so right now, we're all comfortable with that because we all have that same common language. It's just when we start getting letters, we start getting flustered because we don't have a common language. So we'll
Right.
we'll keep introducing it over the next few lessons.
I had just written it
Yeah,
that
Perfect.
top way. So I rewrote it because that's how you wrote it. So for reference.
How you had it was just perfect. Okay, so this page 130 is an interesting one. So it says, let's take a stab at summarizing what we've learned about linear and exponential growth using the calculations for simple and compound interest on this page as models. So with linear growth, the value after a certain time is calculated using the starting value, and then we add a constant
Value.
value a certain number of time periods. So that one, it's a new course pack. And so there's some new different problems, and I'm still trying to figure out exactly what words they want us to put in there. That one makes sense, what I've chosen. The next one, I'm still kind of building on it. So it says with exponential growth, the value after a certain time is calculated using your starting value. What do you
Multiple.
Multiply.
multiply? Yep, that's what I chose too. And you're probably all thinking, and you're the teacher and you don't.
Hmm.
Well, because we have a formal way of putting it together here in a moment. So that's why I'm like kind of being flexible. So we have a starting value multiplying a growth factor
Exponentially.
exponentially. You could put that, or you could say a certain number of time periods.
Just like the above it, where he has it right above it.
Oh, yeah, yeah.
Certain number of time, it's just
Good.
one's adding and one's multiplying.
There you
Good
go.
eye.
That's kind of how I came up with that. So it says, without trying to give it away, answer to 6, what is the significance of the exponent? So the exponent tells us the certain number of time periods, right? That's our exponent, is a certain number of time periods. So in this open space, what I did is I'm taking, they in words down here, they explain in words how to find a linear equation, and down here, how to write an exponential equation. I'm going to kind of give you a little bit more formal up here so you can be introduced to it. So a linear equation is going to be y equals, there's two ways that, but you'll see it written. Sometimes you'll see it written as b plus mx, where b is our original value and m is our added increment. And we call it our, we have formal words for that, or the original value, we really formally call our y-intercept. We'll talk about that in a couple lessons. And our m is called our added increment. So this would be like our $50. And x is our time in years for our situation. Everybody with me so far on that one? So on the exponential, we're doing really fine on time. So on the exponential, the little formal way we're going to write it is going to be a y. So that's kind of our output amount that we've been looking for. And that's equal to, and also, I know most people that take this class they freaked out about algebra. And so they're just like, oh gosh, I'll take anything but algebra class.
Yep.
And we're doing a little bit of algebra, but I don't want you to freak out. That's why we build a story where the story makes sense. And you're like, oh, we were doing algebra? I didn't even know it. Okay. So, and I've had many students, well, maybe not many, but I've had some students tell me after taking this class, like, wow, I kind of want to take an algebra class because I didn't realize that I could do this. Like I could make it make sense. So that's why I want you to take a deep breath when you see me doing some letter equations. It's like, I'm sure it's kind of starting to kind of bubble and you're starting to get a little anxious, but I don't want folks to get anxious. We don't spend a lot of time doing that. We do a lot of allowing Desmos to do the work for us. We're going to allow Desmos to help us make sense of this. Okay. So
I want to say that I actually tried to take, I think, Matt 131 because it said algebra in the title, because I'm not afraid of algebra itself. But when when I was like, quantify, what? No.
Why didn't you take 131 then?
Because she said this was, why take the higher class? I was like,
Oh.
okay.
We're having more fun anyway.
I think it worked
Yeah.
out.
I'm grateful to have some fun ladies to spend my Tuesday, Thursday evenings with.
I took algebra in high school and I was in the military and I took it in the military as well, but it was so long ago. I didn't want to take it because it's like, if you don't use it, you lose it.
Yeah, I
So-
agree with that stuff.
Oh my gosh. Yeah. So I've actually taken it twice.
My daughter's in high school. She's a junior. And I was like, well, I have math, so stuff's coming back to me this year, but she was like, I don't think I want your help.
What?
She said it very nicely, but I was like, okay.
Well, wait until you start showing her how to do all the tricks on Desmos and she.
Although
might-
I did ask her something. I go, okay, help me make sure I'm remembering this right. I'm like, you've done exponents, right? Or I mean, scientific notation. I go, right? Am I doing this right? She was like, yeah.
Scientific notation still kind of trips me up, and I've been doing it for like 30 years, so don't worry.
Well, like the one I sent you the message, I'm like, I thought there's supposed to be a bunch of numbers or zeros still.
Oh, yeah, our conversation the other day. No, I
Yes.
mean, because you know what? That's how you've always seen it. So then it's like, oh,
Yeah.
and there's not. It's like, what?
I don't know. I'm like, this is wrong. This is wrong.
Too funny.
Anyway,
So our exponential is going to be a times b, and then we have our x is in the exponent. So x is still our number of years, our time in years. That's the same. A is our starting value now. Starting original value, whatever you want to call it there. And B is that growth factor. Okay. The growth factor is what we, down here in the purple, the growth factor is 1 plus the growth rate. So I wanted to point that out. The growth factor is 1 plus the growth rate. Okay. Everybody with me so far? Just kind of writing those down so we're kind of getting an understanding of what that looks like. What that's gonna look like. Okay, so number 8. Oh, question?
sorry, I was sniffing.
No, it's okay. And I think my Zoom's kind of being hesitant. So it says, use what you've learned about linear and exponential growth to calculate the value after 20 years in each of the accounts we've been studying. Make sure you write out the calculation that you did. So we'll do a calculation for simple, and we'll do a calculation for compound, and I'll let you do that. And remember, there's different ways we can write them both. So don't get hung up on modeling exactly how I did mine. I'm gonna mute for just 1 minute.
We're just doing the writing out the calculation. We're not doing the math for it yet.
No, we're doing the math.
Okay, just checking. I'm like,
No, that's okay. So we're gonna, how we would do both of them for 20 years, and then finally, we're gonna find the answer. Mhm. You ladies are doing just fine. Let me know if anybody's ready to share. So anybody want to share how we do the simple?
I can. I had 1,000
Mm-hmm,
plus 50,
mm-hmm,
parentheses 20
mm-hmm.
equals 2,000.
Okay. Excellent. And what about the compound?
I got 1,000
Mm-hmm,
parentheses 1.05 to the 20th.
mm-hmm.
Power is $2,653.30. So it was 29.77, blah, blah.
Yep, I'm in agreement with that. 52, I had $53. Did you have 53?
Yeah, that's what I said.
Okay, I was gonna say, I probably just didn't hear you correct. I had both my hearing aids back and I should be hearing, but I just didn't, I missed it. Thank you. Darla and Teresa, are you ladies okay with that? Thumbs up, excellent, okay. So, we're on the downslide of things. The last four problems are a little bit tricky, but it's okay, they're kind of making us think, but not this page, the very last page we're gonna do. Okay, we're gonna do some extension problems here in a bit. So number 9 says, if you borrow $500 at 3% simple interest, the amount you owe after 4 years is given by, so basically just filling it in. So,
Let's see here. The amount you'd have to first give by. So 0.03.
mhm.
So that be 1.03 for the second part. Or no, this is simple.
So what do we start with here?
Oh, $500.
Our original amount, so 500 plus. Then this 500 times the 0.03, right,
Right.
is our interest.
Yeah.
Times our years. Okay. Then 10 says to correctly evaluate that expression, you'll need to remember the order of operations, which says that what comes before what?
Multiplication.
Yeah.
Yeah, comes before
Addition.
addition. So that's why on the previous page, we multiplied the 20 years times the 50 first, right? And then we added that to the original 1,000. So number 11 says, evaluate the expression to find how much you'd owe then. So 500 plus, and then I'm gonna do my 0.03 times the 12, 40.12. And that'll be 60. And I have 560.
Yeah.
Everybody in agreement on that? Then it says, perform the following calculation, then compare your result to 11. Describe what you did in terms of the order of operations. So now we have this and they want us to perform. So what are we going to do first here?
All right, let's see here.
Is it 500 plus 500 with 12 in parentheses?
Point.
0.112?
So, yeah, we have to do the parentheses first. And then what do
I'm
we,
looking at the number up above you.
oh, well, what
It
did
looks
I?
like
here?
0.12.
She
So-
did the 0.03 times 4.
So I did that
Okay.
first. Some people might have done the 500 times the 0.03 first. They're really all three being multiplied, right? So this could be 500 plus 15 times 4, which would still be 500 plus 60, which is 560.
Okay. I'm gonna unmute myself.
Wait, where'd you get 15? Okay.
Is 500 times 0.03 15?
Okay, thank you. Brain foggy. I'm like,
No, that's okay. No worries at all. So now they kind of want us to go through this expression here and write out kind of the order that we would do it. So we have to do what's in the parentheses first, right?
right.
And then inside of the parentheses, what do we have to do first?
Multiply the 0.03 and 4.
Yeah. So we're gonna do the 0.03 times the 4, so that's gonna be 0.12. And then we're gonna do what?
So you're gonna add the 1 to the 0.12.
So 1 plus 0.12. And then the fourth thing would be to multiply, right? The 500 times 1.12. And what do we get?
$560.
560. So we got the same thing. So it says the reason you got the same answers for question 11 and 12 is the blank property of multiplication over addition. Which I mentioned earlier, that same property.
Factoring.
Distributive.
Distributive property. Good job. Then it wants us to come up with some time when an example we can make up using a calculation that uses this property. And I've thought of a couple, but I'll wait and see if anybody comes up with a couple. And you come up with one, and you want to hear mine?
I was just thinking of loans, which they already mentioned.
Yep. Another situation could be like when you go to let's say you go to a restaurant and you have a bill that's $50 and you want to give a 20% tip. So you've got the $50, right? Plus the 20% tip is $50 times 0.20 for the tip. And if you want to find out your total bill, it's 50 plus the 20%. So it's 50 plus 10 equals $60. So that's one way you could do it. Or you could use the distributor property and say it's 50 times 1.2. Because you've got the 100% of the $50 plus 20% of the 50 as your tip. So it's 50 times 1.2, which is 60. This is 50 times 1 plus 0.2. We're not making you come up with examples, but it's good to think about, oh, those are times, or I mean, a lot of times you want to have your tips separate anyway, so you might not need the efficiency of having them as the 1.2. But if you go shopping and you just want to know how much is this shirt going to cost with the sales tax, right? Then you could take your shirt price times 1.06, because that's your one is the 100% of the shirt plus an additional 6% for the sales tax in Michigan. So that's a way that you might use it as an efficiency thing. Any questions so far? Okay, so we have on the last page, it is page 136. The 136. And 136 is asking us to identify each scenario as illustrating either linear growth or exponential growth or neither. So it says show enough work to justify your answer. You don't have to show any work, but this is just for ourselves, but we want to know, like, I wrote on my paper just because I had to figure it out. I've also got Desmos pulled up, so Desmos might help you as well. So let's establish some concepts again about how can we tell if it's linear growth? What did we notice earlier?
Linear is adding the same amount year after year after year, right?
Okay, so if it's linear, we know we're going to have repeat addition, right? Of the same amount. And
Number
if I want
one.
to, and then what about if it's exponential? What did we notice?
That it grows year after year by the same amount, maybe?
No, quite the same amount. The same
meaning-
percent.
Right. I know what I mean to say, I'm just not explaining it.
No, that's okay. That's the more we talk
All
about
I'm
it,
thinking is the curve.
you're right, the curve. And the more we talk about it out loud, the more you'll get words that you're like, oh, okay, that's exactly what I wanted to say. So if we're repeat addition over here, aren't we
Multiplication.
repeating something? We're repeating multiplication over here.
Right.
7 and 10 are repeating.
7 and 10 are repeating.
Yeah, I know 10 is linear. I did see that.
7 is linear.
So how do you know they're linear? What did you find that they're repeating?
They're repeating 2.40. Number 7.
Okay, so you said that we're adding 240 here.
Yeah.
How do you know when it's time to go to the dentist?
Huh?
It's my joke of the day. How do you know when it's time to go to the dentist?
I don't know.
2:30.
Ha, 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 ha.
It's 2:30. I mean, okay, so 2:40. So how did you find the 2:40, Darla? Can you explain that for the folks at home?
I took the 570 and subtracted the 330.
Okay, so you took the second one, subtracted the first one, and then you took the
Correct.
third one and subtracted the second one.
Yep.
And then we had to make sure that they were all 240, right? Because if
Well-
there's one that's not,
Once I found out the 240, then I added it to the 570 to make sure it came up to 810.
good job. So there's lots of different ways you can do it. Okay, so does everybody agree this one's linear then?
Yes.
Okay. And then you said you thought 10 was as well?
Yeah,
Okay, so what's the deal on 10?
1500.
15.
Okay, so
15.
this one is a linear of 1500. Okay. So the linear, the adding thing is not too stressful. And if it was linear, they did want us to try to find the next value. So up here, 1530, to find the next value, if we added 240, we would get
1770.
Yeah.
Okay. And down here, if we added 1500, we have 49,000.
40. Oh, yeah.
Is that right? Okay.
Yeah,
Yes.
49,000. Yep.
Okay. So now we have 8, 9, and 10. So if 8 were to work for linear, then this difference here would be 1200, right?
Mhm.
And then they would all have 1200, but does that work?
No.
No. 'cause
Mm-mm.
14,000
that
would be 14,400, so that's not right.
That one's an exponent of 1.1.
How did you find that, Sandy?
I took the value because I could tell it wasn't linear just by subtracting the first sets of values.
Mhm.
So I then took the 13,200. I divided it by 12,000. I got 1.1. So then I took my 13,200 and multiplied 1.1 and it went up. the same.
Okay, I love it. So notice, and I think you all had mentioned this. Oh, something popped up. Can you all see my Desmos?
Yes.
Okay, so I think everybody's making the connection that if you want to find out the addition thing, you have to use the inverse operation of subtraction to kind of work that backwards. And then I noticed Sandy made the same comment that she wanted to find the multiplication thing. And so she used the inverse operation of division to find that backwards. So I'm just going to show on Desmos how folks at home could be doing this. So the first one is you take the second value, 13,200, and she divided by 12,000 and found that that multiple, that growth factor would be 1.1. And if that were true, then she could take 13,200 and multiply by 1.1 and to get the next one. And that worked. And then 14,520 times 1.1, and she'd get the next one, right? And actually, right in that same line, I could just say multiply by 1.1 again and see if it goes to the next one, right? It went to 17,569.20. And right in the same line, I'm just going to say times 1.1 again. And sure enough, it went to 19,326.12. So that proved our growth factor of 1.1. So that means if we multiply by 1.1 again, our next line should be 21,258 and 73 cents.
Yeah.
So it's exponential. Okay. You all are doing awesome. So I just want everybody to see my paper, what we came up with there in that one. And then, and I always check, personally, I always check the linear first, just because it's the easiest one to check first. Unless you can kind of see, oh, it looks like it's doubling, like that sometimes
Yeah.
it's gonna pop out at you. So what about 9? Is that linear?
No,
No.
you can tell by looking at it, it's not.
Okay.
I think it's exponential, and at first it was throwing me off, but then I see it's population, so they're not gonna have the percent, the decimal point, so they're gonna round.
Okay,
Which
I
is
like that.
why I've decided that it's exponential 1.0.
Okay, you said 1.02?
Mhm.
Okay.
It's neither.
And so, yeah, that's a good one because the first time I did it, I said neither because it wasn't quite 1.02 on all of them. But Sandy brought up a good point that I didn't even, I've done this is my 3rd time doing it this week. And I still didn't think of it until Sandy just said, because the topic is population, and so they would have to round to the nearest people. And so that's why the percentage has to be rounded. So it's okay to round those 1.019s to 1.02. I didn't think about it either. So the first one, 10,200 divided by 10,000 is the 1.02. And then we divide by 10,000. Oh no, 200. Oh no, we don't want to do that. Just stick with this here. So if it's 1.02, then the 10,200 times the 1.02, right, should give us a
Mhm.
104, and that works. Times the 1.02 should give us rounded 10,612. Times the 1.02 would give us, oh geez. Forget what I did up there. 10,612 times the 1.02 gives us the rounded 10,824. So that is an exponential as well. Okay, so then the last one, if we wanted to find the next value, would be 11,
It's all
261,
over.
262.
Yeah, we have to round that up. Okay, and last but not least, we actually have 5 minutes to spare. You guys are doing awesome. So what do we think for this last one? Can we make it work for anything?
No. The numbers are
Yeah.
either 2
No.
apart, 3 apart, 8 apart.
Mhm.
No, that figures it's stock price. Of course, it's not.
You're right. And we're going to talk about stock price on the Unit 2 project. So I'm going to get some of those videos made and everything. So the Unit 2 project's up here in the next couple of days, because I know folks want to look at it and get some stuff going on that. And giving everybody a heads up, on the 18th of whatever that is, no, the 14th of October, I won't be having any live Zoom sessions, but it kind of wraps around the end of Unit 2. So you'll have, that'll be kind of a free day that you can work on the Unit 2 review, finish up your Unit 2 project. Then the next week, we come back and we finish Unit 2 together. There's like one more section, I think, depending on if we might get a little ahead. So this Thursday, 2.2 goes fairly quickly because it's some unit stuff that it's graphing, which a lot of people are somewhat familiar with graphing, and we're going to do is we'll get through that kind of quickly. So I'm hoping to get a jump start on 2.3 and kind of maybe get a little ahead for that day that I'm not having a live Zoom session. And then at the week after I have my the 14th, when we won't have the live Zoom session, we'll have like a review day together. So that'll be good. We'll kind of come back together. We'll make sure everybody's doing okay on the project. Like I said, I'm fairly sure the Unit 2 project will go smoother than the Unit 1, because I've done this before. Unit 1 is always definitely some frustration. And not having to use Excel, you'll be using Desmos, which you're getting more into anyway, because we're doing Excel in class. So students you'll become very familiar with Excel. I mean Desmos, I'm sorry, not Excel. You're probably getting too close to Excel at this point. So any questions before we go tonight?
I'm good.
Everybody's good?
Thank
Okay.
you.
So keep plugging along. Let me know if you need help before Thursday.
Yeah, finish up that project.
And that's what I'm saying. Don't stress about the project.
Yeah.
Like I said, get in, do the main categories, do the main things. If you end up, doing a circle graph by hand, I don't care. If you end up doing your bar graph by hand, I don't care. And then there's a big video where I really went through the population thing on 1.7, but I'm happy to kind of walk through that again with somebody if you need me to.
Yeah.
I have
That's
that
what-
open in
that's
the
what-
save tab.
Yeah, that was what confused me, was because when I went to it and I tried to click on it, it was read only and it wouldn't let me do anything, but then you went in and showed me on, and I watched that video that you did for that part of it, for
Okay.
task 4, so.
Okay, good.
I believe me, I will email you if I have any more questions, so.
Awesome.
Okay.
Okay, have a great night, everybody.
All right.
Bye.